the neutralization effect of acid and a base. But when the alkali is more than what it is required and the metal, usually it is a transition, usually I say it is a transition which have more than one valency, and they can have a coordinate bond with the ligands. In that very case, we can have a coordinate compound. In getting the coordinate compound, I would rather say in 2004 at Geneva, IUPAC had made the nomenclature, that the way that one should write the compound. I have the compound, say FeCN6. The CN6 is the ligand, this the metal atom, this the total is the coordination entity, and I have already told you that when the ligand is usually it is a neutral, the ligand is usually neutral or it is negative. When it is negative and ends with IDE or ITE or ATE, we remove this E as O. So we have to write as IDO, ITO, ATO and so on. Like for example, carbonate, CARBONATE, carbonate. So you can see here CO3, 2 minus. It's ending with ATE. I will rather write it as ATO. Nitrito, TRITO. So we can write this instead of nitrite, nitrito, chlorido, CHLORIDE, chloride. Cut this E and add O. This all we have discussed before. Today we are to discuss more on this type of compounds which is having a coordination. I have got a handful of these elements. I am going to make you know about this in detail. For example, if we take the first case as FeCN6 to the power 4 minus, here we can say FeCN6 4 minus. Here we can understand the entire coordination entity is anionic, it is negative. And when it is negative, we have to use the word ATE. Like first, what is the first thing to do is, this metal should have the oxidation number. We have to calculate the oxidation number as X, this minus 1. So here we can have X minus 6 equals to minus 4, X equals to 2. So we can write it as hexa, HEXACYANO, hexacyano, ferret, FERRATE, ferret 2 ion. So here we can have the name as hexacyanoferrate 2 ion. Remember, when you write the compound, you have to write the ligand first, followed by the metal atom. In the second case, we can write here, say KAgCN2. In this case, you have to write the counter ion first because it is found out of the coordination part. So you have to write here potassium and followed by dicyano, CYANO, cyano, argentate, ARGENTATE, argentate 1. Why I wrote argentate 1? Because this, you know, it is plus 1, this is minus 2, and ultimately the total coordination is 0. So you can write it as X. So plus 1 plus X minus 2 equals to 0. X is equals to plus 1, so argentate 1. Student, when we go for such big complexes, let us see, for cobalt, chloride, nitro and amine. In this case, you can see here what's the oxidation number here, let us take X, -1, and 0. So here we have chlorine, this cobalt as X -1, -1 into 2 is -2, -1 plus 0 equals to 0. So X is equals to 3. Here we write like this. This is according to the alphabetical order. Here we write ammonia as amine, triamine, chlorido, CHLORIDO. So we have to write in the alphabetical order. First amine, then chlorido, but chlorido is here 2, so we have to write here dichlorido, CHLORIDO, dichlorido. Here nitrito, 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 N, because nitro group, NO2, is an amphimented ligand. So here it holds the cobalt with the nitrogen. So nitrito, N. Now cobalt is 3 as we know it, COBALT, cobalt 3. So this is the name of the compound. And very interesting thing is that you have to write the name of the ligand first, followed by the metal without having any gaps in between. There should not be any gaps, and it is better always you write with a small letter. If I take that very compound as CrCl2 H2O whole 4 NO3. Here we have tetra aqua, T-E-T-R-A, tetra aqua, A-Q-U-A. Be sure that you write A for tetra, A for aqua. Don't fix it as single A, otherwise you will be making wrong. Dichlorido, C-H-L-O-R-I-D-O, chlorido. Now chromium, C-H-R-O-M-I-U-M, chromium 3. And then nitrate, give a gap and then nitrate, N-I-T-R-A-T-E. Now the question is how I know this chromium 3. You can check it here, -1, this is 0, this is -1. So -1 into 2 is -2 and -1 is coming -3. So chromium should be of +3 standard. So tetra aqua dichlorido chromium 3 nitrate. In these bridging ligands, here you know this is the nitrito, this is the amine part. So we can write this as X, and here X, this is 0, this is 0, this is -1, this is -1, and this is -1. So what's the value coming up? 0, then X, -1, -1, this is nitro group, this is the amine group, -1, then 0, and then -4 is equal to 0. So here you can see this one more X, here one more X plus 0 equals to 0, or 2X equals to 6, or X equals to 3. So cobalt here is +3, cobalt is +3. We write like this as tetra, T-E-T-R-A, A-M-M-I-N-E, tetraamine, cobalt, C-O-B-A-L-T, cobalt 3, and then we have to write the bridging element. So in breaking the bridging element, we have to use the word mu. We have to use the word mu, and this NH2 is called as amido, A-M-I-D-O, amido. NH2 amido. Here another bridging element, mu, nitrito N, N-I-T-R-I-T-O, nitrito N. Again cobalt 3 would be there with tetra, T-E-T-R-A, tetraamine, A-M-M-I-N-E, amine, cobalt, C-O-B-A-L-T, cobalt 3 space nitrate, N-I-T-R-A-T-E, nitrate. So student, you can see how big the name is. It is tetraamine, cobalt 3, Then you go for the bridging. Here this is for writing the bridge, you have to use the word mu. This is what we call it as mu, mu, mu. So mu amido, mu nitrito. In this case again amido nitrito N. This is nitrito N because it is a ampidentate ligand. Then tetraamine once more, cobalt 3 and then nitrate. Similarly, if we go for the next one, if we go for this next one, let us see, calculate out. Water is 0, water is 0, this is -1, -1, this is -1. So -2, -1 is -4, this is x and x. So 2x equals to 4 and x equals to 2. And how we write here? Iron is +2, iron here also is +2. We write here tetra aqua, T-E-T-R-A, tetra aqua, because water we call it as aqua. Iron, I-R-O-N, iron 2. Then hydroxo, we call it as hydroxide, but here we will be calling it as hydroxo. So mu hydroxo, H-Y-D-R-O-X-O, hydroxo, mu hydroxo once more. Instead of writing this, mu dihydroxo, you can write it as. So mu dihydroxo, tetra, T-E-T-R-A, tetra aqua, A-Q-U-A, aqua, iron 2, and then space sulfate, S-U-L-P-H-A-T-E, sulfate. So this is how we do it. So once more you can see tetra aqua, iron 2, mu hydroxo, instead of writing twice I can write it as mu dihydroxo, tetra aqua, iron 2 and then sulfate. Similarly here En, ethylene diamine or ethane 1,2-diamine, this value is 0. Here this is -1, this is also -1, this is -2 rather, not -1, -2. So this is -2 and -1 is -3. So this -3 when it goes here, so you can see here that if this is x, this is x. So 2x -2 -1 equals to +3, 2x equals to 6 and x equals to 3. So here we write like this. Bis ethane, E-T-H-A-N-E, ethane 1,2-diamine, bis ethane 1,2-diamine, cobalt is 3, C-O-B-A-L-T, cobalt 3, and NH is called imido, so mu imido, I-M-I-D-O, mu imido, mu hydroxo, H-Y-D-R-O-X-O, hydroxo. Again, bis ethane 1,2-diamine, ethane 1,2-diamine, bis ethane 1,2-diamine, this should be A-M-I-N-E, amine. Bis ethane 1,2-diamine, cobalt, C-O-B-A-L-T, cobalt 3 ion. Such a big name we have for this compound. When we go for chlorine, we call this as dichlorido, C-H-L-O-R-I-D-O, dichlorido. When we go for CN4 tetra, T-E-T-R-A, tetrachlorido, C-H-L-O-R-I-D-O. Now the question is, when you go for En, the whole 2, then we call it as bis, ethane 1,2-diamine, ethane 1,2-diamine. Now the question is, why we use for 2 bis, 3 tris and 4 tetrakis? Why we go with this? The thing is, whenever you have a die and before that you cannot use one more die, you have to use bis, tris and tetrakis. Like EDTA, it is ethylene diamine. So you can see this, if it is 4, then you have to write here TETRAKIS, tetrakis, and then EDTA, about EDTA, it's so big enough, so ethylene diamine tetraacetate. So this very big compound, if it is occurring 4 times, you have to write tetra. If it is having CEN whole 3, then you have to write here tris. Why? Because you are already using di, here you are using tetra, TETRA, acetate, ACETATE, tetraacetate. The word, when you use tetra, once you have used it, you cannot use it twice. So in that order, you have to use bis, tris and tetrakis.